Hi, math friends. This is Kristen Hilty from Making Math Make Sense. This video is going to talk about how to use Math Talk at home with your kids, especially in grades 3, 4, and 5. One of my favorite phrases I like to share with teachers of all grade levels is that math is not learned in silence. It's not the way it was when many of us were in the classroom, when we sat in rows and everybody did their own individual work. In order to get our kids to become the deep mathematical thinkers we're looking for, we need to have our kids talking and sharing their ideas, sharing how they see things, and what strategies they're using in order to solve problems. And one of the best ways to encourage kids to do that is to use pictures. Sticking with our theme for this series that we've been doing, I'm going to continue in this for the first part of this video to use this picture at the beach. Yes, I know it looks like a primary picture that we use with our younger age students, but we can also use those pictures with our intermediate students as well. What we're going to do is we're going to change the focus of our questions here. So looking at this picture, I could ask my kids a very basic question of how many people are at the beach today? Yes, they're going to be able to see that we have 11 people at the beach, but now I'm going to change it and I'm going to say, okay, how many toes do we have at the beach today? How many eyes do we have on the beach today? Have kids explain their answer. Some of them are going to also focus on the animals in the picture. If I just leave the open-ended question, how many eyes are at the beach today? Well, we know each person has 2 eyes, but then you can see those 3 fish jumping out of the water. You will have students who will count their eyes as well, or they'll also get the crab in the front of the picture and they'll count his eye, or the bird that they see next to that green blanket. So when kids give you an answer, be sure to follow that up with, well, how do you know? What is it that you were looking at? So don't just go with just the answer, make sure that the explanation follows through. I could then say to them, okay, let's say a family of 4 decides to have a picnic at the beach. How does that change our numbers? Now, how many toes do we have? Now, how many eyes do we have? How many hands are at the beach? How many fingers are at the beach? I can ask questions like that. I can also use pictures like this to talk about fractions as well. So I would say to my kids, let's focus on that green and white umbrella, and let's pretend that we are a bird flying overhead. We look down on that green and white umbrella. What is the fraction of the green sections you would see? And how do you know? Have kids think about that and be able to explain their answer. Many kids are going to say 1/2 or 3/6, and I follow that up with, okay, explain, what would the pattern be? If my answer was 3/6, my pattern would probably be white, green, white, green, white, green, or an AB, AB, AB pattern. But I might have a child who says, well, I think it would be 2/6 or 1/3. And I would say, okay, explain your pattern to me. And they see it as a mirror image. So they would see white, green, white, white, green, white. So they would have that mirror represented. Both answers are correct. I might have a child say, I think it's 1/6. Okay, why? Well, because I think the other side is all white. There's only one green section on the umbrella. That is a possible answer. You can bring probability into this. And what is the probability that it would be 1/2? What is the probability that it would be 1/6? So we can talk about different situations as far as that goes as well. I could also bring geometry into my picture, and I could have kids find quadrilaterals. And using the hierarchy of quadrilaterals, have them explain all the different ways that they could name it. What are all the different ways you could name that red blanket? Give me the attributes that make it a parallelogram, that make it a rectangle. I could have them talk about 2-dimensional shapes in the picture versus 3-dimensional shapes. Again, focus it on the attributes. Triangles. I could have them look at the triangles in the kites, and I could have them name all the different ways that the triangles are represented, having them name them by the sides and by their angles as well. If I look at the kite on the left, does the yellow section represent 1/3? Why or why not? There are different ways that I could look at that. If I'm looking about the space that the yellow section represents, then my answer is no, because we can see that that is not 1/3 of the space on that kite. But if I'm talking about fractions of a set and I'm talking about the colors that are represented on that kite, then yes, yellow does represent 1/3 of the colors on the kite. Again, get that justification piece out there from your students. Ratio. This is a great picture to bring in ratio. What is the ratio of people flying kites to people on blankets? What percentage of the people at the beach are flying kites today? What is our ratio of sandcastles to shells? What is our ratio of children to adults? And again, I could turn that ratio into a percentage as well. So you can see, even though the picture looks to be primary, there are many intermediate concepts that I am able to pull out of that picture. I can also use pictures to have kids find vocabulary words that we're focusing on. So I can have them find the vocabulary word, use that vocabulary word in a sentence describing how they see it within that picture. Bring in real life photographs. Have your kids take pictures or bring in pictures from a trip that they've been on, or look on National Geographic. They have great pictures out there as well. This is a picture here that we took on a trip that we were in Chicago. And stadiums are a great place, also connecting kids to sporting events. Use this for estimation of large numbers, about how many people fit in this stadium. If it were half full, about how many people would that be? A quarter full, 3/4 full. Patterns, I could use patterns in that picture. Here I can talk about attributes of three-dimensional shapes that I can see within this picture. This is a great one for giving different story situations. If that statue is about 10 feet tall, about how tall do you think my daughter is? Estimate the number of toes that are in the museum. This one here is great for arrays, about how many people are represented on this wall. Having them give talking about those window washers. If each window washer has to wash 50 windows, how many windows do they have to wash altogether? How many would they have to wash in an hour if they worked a 6-hour day? So I can put rate problems in here, time problems in here. I could talk about capacity with the water in that picture there. Use scoreboards. Scoreboards are a great place to find numbers that we can talk about that can be represented in real life situations. Talk about batting averages. Talk about an ERA from a pitcher. Having kids working with decimals and understanding that. One of my favorite resources is Which One Doesn't Belong. You can find this online. You can do a search for Which One Doesn't Belong. The way it works is that you're given 4 pictures. I like to label the pictures. The top left A, top right is B, bottom left is C, and bottom right is D. And my question is always the same. Which one doesn't belong and why? This is great for kids to have to give justification. So I could look here and I could say, okay, tell me which one doesn't belong. And I could ask, how many of you think A doesn't belong? Many people will say A. My follow-up question is why? It's the only one with 3 sides. Look at B. Who can give a justification as to why B doesn't belong? Oh, it's the only one that has 4 90-degree angles. How about C? Who can give a justification for C? It's the only one not colored in yellow. And then look at D. What's your justification for D? Well, we can see that that one's the only one that's resting on a side. The others are resting on an angle. So the way Which One Doesn't Belong works is that there is a justification for each one not to belong to the other 3 within the group. You can see here is another example from that. As I said, if you do a Google search for Which One Doesn't Belong, you'll be able to find lots of different images, and those images will range from preschool all the way up through a high school level, where you can get kids to participate in that. Our big takeaway from all of this is that math is not learned in silence. Have kids have fun talking about the math that they see all around them. Feel free to let us know if you have any questions or comments, or post pictures of different ways that you are getting kids to enjoy talking about the math that they see. Thanks so much for joining us.